In an enterprise environment, developer speed and central IT security often pull in opposite directions. As data streams multiply and workload demands increase, traditional infrastructure controls reach a breaking point, failing to protect the system without halting progress. Many organizations attempt to use their existing on-premises operating models in the cloud. These models rely on static, ticket-based provisioning that was designed for physical hardware with long life cycles, making them incompatible with the near-instant nature of cloud resource allocation. This mismatch creates severe bottlenecks. When a development team requires a new environment, they are forced into manual queues for security reviews and architectural sign-offs, causing projects to stall for weeks. To maintain their timelines, workload teams eventually bypass these central controls. They spin up unmanaged resources using personal accounts, creating a landscape of shadow IT that is invisible to the organization's security team. Microsoft addresses this disconnect through the Cloud Adoption Framework and the Azure Landing Zone architecture. The Azure Landing Zone provides an architectural compass based on a set of core design principles, rather than a single, rigid configuration. To see how it works, we will construct a scalable enterprise environment from first principles, building the structure through governance, network topology, and automation. Aligning these foundational layers is the only way an enterprise can achieve cloud scale while maintaining a consistent security posture. Traditionally, cloud subscriptions functioned primarily as billing boundaries, a method for the finance department to track which business unit was spending what. In the Azure Landing Zone architecture, the subscription is the fundamental unit of management and scale. It serves as the primary container for organizing and securing Azure resources. This shift enables subscription democratization. Subscriptions become the management boundary, transitioning control directly to teams. In legacy models, central IT teams hoard control, placing all workloads into a few massive shared subscriptions. This creates constant friction as multiple teams compete for the same network address space and access permissions. A standardized subscription vending process gives teams isolated environments automatically, but this autonomy introduces compliance risks, like exposing data publicly. Policy-driven governance mitigates this. Before handoff, subscriptions are wrapped in platform-level guardrails, preventing non-compliant actions. Azure policy enforces these security and regulatory controls agnostically across all tools and deployment channels. It acts as a continuous audit and enforcement layer within the platform itself. These automated guardrails eliminate the need for central IT to manually inspect every resource, as the platform itself prevents unauthorized configurations from ever being deployed. Wrapping democratized subscriptions in policy allows workload teams to move at high velocity within an environment that is secure by design. While individual subscriptions are easy to manage, large enterprises must coordinate hundreds of them simultaneously across diverse business units. Managing this volume requires a logical hierarchy that can organize these subscriptions based on their specific technical requirements. Many organizations group their subscriptions by environment, creating separate management branches for dev, test, and production. However, this forces IT to duplicate network routing and security rules across 3 different areas.
These configurations often drift apart over time, leading to production environments that don't match the security standards of the testing phase. To avoid this drift, the Azure Landing Zone groups workloads based on their network routing and exposure profiles, rather than their development stage. Management groups apply shared security policies to sets of subscriptions. The Corp group hosts internal applications, routing through private connections back to on-premises data centers. The Online group isolates public-facing resources, ensuring internet traffic cannot reach sensitive internal systems. Isolating workloads by network profile drastically reduces the attack surface. A compromise in an online subscription is physically unable to move laterally. Managing traffic between these zones requires a central hub, the Connectivity Management Group. This hub hosts the organization's centralized networking resources, such as Azure Firewall, virtual WAN hubs, and ExpressRoute circuits. It acts as the single gatekeeper for all traffic entering or leaving the cloud environment. Using macro topological isolation by network profile ensures that security boundaries are enforced consistently across the entire enterprise, regardless of how many subscriptions are added. Building this architecture is only the first step. The next challenge is maintaining and updating this complex topology as the business grows.
Scaling requires platform automation. Every component of the landing zone deployed as infrastructure as code. Automation is only effective if it uses a single control and management plane. This ensures that the same commands and security logic apply across the entire enterprise estate. Azure Resource Manager serves as this unified control plane, providing a consistent interface for all deployments. However, introducing third-party abstraction layers or custom portals creates a disconnect. These tools can obscure errors and limit access to native features. These external tools often lag behind the native Azure platform. Relying on them creates integration complexity that prevents teams from using new cloud capabilities as they are released. This deviation eventually requires manual intervention to fix synchronization issues, resulting in the very operational overhead that automation was meant to eliminate. Adopting a native infrastructure as code strategy is the only way to ensure the environment remains repeatable and manageable as it evolves toward enterprise scale. We have now identified the 3 core pillars: policy-wrapped subscriptions, network isolation via corp and online management groups, and native automation through a single control plane. These pillars are the building blocks of the Microsoft Cloud Adoption Framework reference architecture. This model provides the target state for a well-governed enterprise-scale Azure environment. This design creates an application-centric service model. It provides a universal, secure foundation that supports both traditional virtual machines and modern cloud-native services without requiring different security structures for each. Moving away from these principles leads to fractured governance and security gaps that grow wider as more workloads are added to the cloud. Achieving enterprise scale requires the relentless deployment of highly automated, standardized, and policy-governed units of management. By utilizing Azure landing design principles, an enterprise can finally align developer speed with the rigorous security standards required to operate in the cloud.